Welcome to the Problem Solving in Geometry and Algebra lecture video for page 24. Watching this video and taking very careful notes on it before working on page 24 will definitely make your life much easier. The first thing I want to talk about is the Troisi triangle, which we've discussed in class before, but just a little reminder. The Troisi triangle is very helpful when you're dealing with any kind of distance, rate, and time problem. Again, the way it works is once you know the Troisi triangle, if you want to find the distance, then if you cover up the distance, what's left tells you that distance must equal the rate times the time. If you want to try to find the rate, covering up the rate shows you that the rate equals the distance divided by the time. So it's just a nice little way to remember all the possible formulas. You could quickly write them down. So distance must equal rate times time. Rate equals distance divided by time, and of course time must equal distance divided by rate. Remember, using units can also be really helpful here. If the units are all set, then you can almost derive the formulas yourself. Quick example of that: if the distance is in miles, we know the rate would be in miles per hour, and since time would be measured in hours, the units work out. Obviously I've got an hour on the top and an hour on the bottom, which is really just a way of saying 1, and then you have miles equal miles, which looks good. If you mess up the formula, the units won't work out nicely and you'll be in a little bit of trouble. When you're also doing these problems, problem number 1 is a little tricky, but it's much easier if you define your time carefully. In this one, it might be easiest to define the time as minutes since the parents leave home. You could also define your time as the minutes since Morgan left home, but as long as you're consistent in writing down your equations, it shouldn't be too bad. So just remember to use the Troisi triangle and define your t very carefully. Next little reminder, which you probably already know, is perimeter. We're going to do some problems here dealing with perimeter, in which case perimeter is simply the distance around a figure. If it's a square, perimeter is just 4 times the length of each side of the square, often symbolized as 4 times s. A rectangle would just be 2 times the width plus 2 times the length. You'll just need to use perimeter in one of the problems on this page. Now we're going to do a little calculator practice, and this is something you've probably never done on your calculator, so pause the video if you need to, go grab your TI-84 and come on back. What I'm going to show you how to do with your calculator is how to do what's called scatter plots. First, we'll enter data in lists, and then I'll show you how to graph those points on your calculator. So pull out your TI-84. Zoom in a little bit here so it'll be easier for you to see. First thing, obviously, you need to turn your calculator on. And then press the stat button. So again, if you need to, you can just rewind the video, nice and easy. But hit your stat button, and you'll notice it says edit. So if you simply hit enter, it will take you to this screen. The L stands for lists. There's list 1, list 2, list 3, other ones. Right now we're just going to need list 1 and list 2. The easiest thing to do is put your X's in list 1 and your Y's in list 2. So all we're going to do is we are going to plot 3 different points. Let's plot the points 2, 5, 4, 7, and negative 2, 1. So if I want to plot all 3 of these points, in list 1, I'll put the X's. So just type in 2, hit enter, it'll take you to the next point. We'll type in 4, hit enter, and then type in negative 2. Remember, the negative is this key here, not the minus key. This is the negative sign key. Put a -2 there. But now we'll just scroll over to list 2. In here we want the points 5, enter, 7, enter, and 1, enter. So now what we've done is we put these 3 points into our lists. The next thing we need to do is we need to turn on the plotting capabilities of your calculator. So do second y equals, which you'll see says stat plot. So go into the stat plot. Right now your calculator probably looks like mine where it says the plot is off. So we need to hit 1 to enter and then hit enter again. Notice it's flashing on the on. So if you hit enter, we're good. Right now it's highlighting the correct type of plot that we want down here. You could do different types. For our purposes, we'll always want this one, so you should be good. And notice it's set up so that the X list is L1 and the Y list is L2. So now that we've got this turned on, all we have to do is graph it. And you'll notice we've got the 3 points. And if you look carefully, it pretty much looks like one is at 2, 5. One is at 4, 7, another is at -2, 1. Notice it also drew a line. The reason mine drew a line is because in my normal y equals, I actually have the equation -2x plus 1. So it's actually nice. You can plot some points and you can graph a line on there. It might be a nice way. Clearly I can see that these points do not lie on the line -2x plus 1. They look like they might be collinear. And you can maybe verify that by figuring out the equation between these 2 points with the slope and the y-intercept. Then you can graph that equation into y1 and see if all those points lie on the same line. So it's really handy. Just practice this a couple of times. You'll need to use it on one of the problems of page 24, but it's a really nice skill to have. Next, I want to talk about finding percentage increases. A lot of times in a problem, it'll say that some number has increased by a certain percentage. Let's do an example of a 12% increase. Remember, the easiest way to do this is to take whatever that number is. Let's say it's 40. To show a 12% increase in 40, I need to multiply with something more than 1. Because if I multiply it by 1, it'll stay the same. The only way I can get it to increase is to do it by more than 1. So a nice way to show what 40 becomes with a 12% increase is multiply it by 1.12. And if you think about it, where this comes from, the 0.12 is 12%. Percent being the root of 100, so 12 per 100 is really what 12% means. That's why multiplying 40 by 12 over 100 gives us 12% of 40. Obviously, 40 divided by 100 is the same as 4 divided by 10. 4 times 12 is 48. 48 divided by 10 would be 4.8. That's just 12% of 40. But obviously, if it's a 12% increase, 4.8 is not 12% bigger than 40. That's why we need to keep the 1, which is kind of like adding 40 to it. But if you look at this carefully, you'll get the same thing if you simply do 40 times 1.12 all at the same time. If you want to, feel free to just pull out your calculator. 40 times 1.12, 44.8, thankfully gives us the same answer as when we did it with fractions. So to find a percentage increase, we just need to multiply by 1 point and the percentage. A percentage decrease is a little different. An 8% decrease is going to have to be less. This is a little tricky, but the best way to do that is to figure out 1 minus 0.18. 1 minus 0.18 is 0.82. We'll do a quick example. If I had $100 and I lost 18% of it, clearly 18% of $100 would be $18. If I lost 18% of it, that would give me the 82. Well, notice if I multiply 100 by 0.82, I will get the 82. which should show us how much I have after an 18% decrease. Another way to think about it is this subtraction is because 1 times 100 is the amount that I originally had, but then I lost 18% of 100. Well, clearly I can simply factor the 100 out of both of these, which will always leave me with 1 minus 0.18. So that's the easy way to find a percentage decrease, is simply to take 1 minus the percentage and multiply the original value by that new number. In our case, 100 times 0.82 tells us that we'll have $82 if we lose 18% of our $100 investment. One more quick little reminder. I think you already know how much I love the zero trick for inequalities. And this comes in really handy for a couple problems on this page, so I just want to go over it real quickly. Again, you can memorize some formula about when you divide or multiply by a negative, switch the sign, but I think that's a little tenuous. Let's do this one as a quick example. Really, all you need to do is solve this equation for x. So now we're going to ignore the inequality sign and solve this guy for x. I'll get negative 4x when I subtract 12 from both sides. 20 minus 12 is 8. Divide both by negative 4, so my x is negative 2. So I know that on my number line, let's call this 0, call that negative 2, this is the part that's going to be important. This is the boundary between the two places on the number line where this must be true. Since it's not equal, I'll put a nice little circle there. Since we know a circle means it can't equal that number, a filled in dot means it could equal that number. And I'm going to do my zero trick, which simply means I'm going to plug 0 into this original equation and see if it's true. Obviously, when I plug 0 into here, negative 4 times 0 will all just become 0. And I'm left with 12 less than 20. And I ask myself, well, is 12 less than 20? It is less than 20, so this checks out. Meaning that 0 has to make this inequality work. So I know that 0 is a point on here. Well, obviously if 0 works, then I don't want to shade in things on the left because that would not include 0. I always want to shade things in on the right. And again, a little tip, if this is on an assessment, feel free to do the negative trick if you remember it. Meaning first we would subtract 12 from both sides to get this. So we'd have negative 4x is less than 8. And then when you divide both sides by negative 4, since you divided by a negative, you need to reverse the inequality sign. You get x is greater than negative 2. Works out. But again, it's easy to make little mistakes on a test. Feel free to do it this way. Then also do the zero trick. Make sure you're right, and then you're in good shape. When you hand in your paper, you'll know that you got 100. I won't even need to grade it. That would be great. Thanks for your attention, and good luck on page 24.